Welcome. In this e-learning module, I shall demonstrate and make you understand how to design the die shoe. The die shoe's function is to absorb the force coming from the die plate and die back plate. The die shoe is also used to fasten the die assembly to press bolster using U-slots. The die shoe also has provision to mount the guide pillars. Usually, the length and width of the die shoe will be more than the die plate, to accommodate the U-slots and guide pillars. The thickness of the die shoe will be more than or equal to the die plate's thickness. Now, let me demonstrate how to design the die shoe in CONTIA V5. Measure the distance between the front surface of the die plate and the head of the shoulder bolt. The measured distance is 58 mm. The strip pusher could get damaged during the lifting and handling of the die assembly. Hence, I prefer to design the die shoe 60 mm extra. I want the die shoe to provide some protection to the strip pusher. Like the die back plate, to design the die shoe, let's use the die plate. Right-click on the die plate and open it in the new window. Let's save this die plate as die shoe. Click on the file, Save As. Don't forget to click on Save as New Document, as we need a new file named die shoe. Change the file name as die shoe. Then save the file. Close the die plate. Open the die shoe. We will follow the same approach that we had followed to design the die back plate. First, let's change the size. Right-click on the sketch, which defines the size of the plate, and pick Edit. Add 60 mm to all the four dimensions, which defines the length and the width. Make sure the sketch is fully constrained and exit the Sketcher workbench. Observe the holes that are positioned at the corner of the plate. We need to move them inside by 60 mm. Right-click on the Fastener Location sketch, and pick Edit. Add 60 mm to all the four dimensions, which defines the edge distance of the holes. Make sure the sketch is fully constrained and exit the Sketcher workbench. Observe the holes of the strip guide plate are still positioned at the corner of the plate. Right-click on the Fastener Location sketch of the strip guide plates, and pick Edit. Add 60 mm to all the dimensions which define the edge distance of the holes. Make sure the sketch is fully constrained and exit the Sketcher workbench. Let's redefine the counterbore hole provided for fastening the die plate into a threaded hole. Right-click on the counterbore hole and select Definition. Change the counterbore hole to a simple hole. Define the hole as threaded. Change the thread definition type from no standard to metric thick pitch. Ignore the warning, pick OK on the warning message. Select M10 for the thread description. Enter 20 mm as thread depth. Remember, the thread depth should be a minimum of 1.5 times the thread size. Click on Preview, make sure the hole is getting created, and then click OK. Observe all the counterbore holes that are updated to threaded holes. Now we need to redefine the relief hole provided for the dowel hole. The relief hole should be provided from the plate's bottom, as the dowel will be assembled from the top. Right-click on the sketch of the relief hole and select Change Sketch Support. Ignore the warning, pick OK on the warning message. Observe the sketch support is present on the top of the plate. Pick the bottom of the plate. Observe the sketch support move to the bottom of the plate. Pick OK. Right-click on the relief hole and pick Definition. Observe the hole is not in the correct direction. Pick the reverse direction on the hole definition window. Pick OK. Observe both the relief holes of dowels are updated. Now let's delete the threaded hole provided for the strip guide plate. Pick the threaded holes in the user pattern associated with the hole. Right-click and pick Delete. A delete window opens. Uncheck the Delete Aggregated Elements. Pick OK. Let's delete the dowel holes provided for the strip guide plate. Pick the dowel hole in the user pattern associated with the hole. Right-click and pick Delete. A delete window opens. Uncheck the Delete Aggregated Elements. Pick OK. Change the view display to the wireframe. Let's redefine the relief hole provided for the threaded and dowel holes of the strip guide plate. Right-click the relief hole and pick Definition. Change the hole extension from blind to up to last. Click on Preview, make sure the hole is getting created, and then click OK. Change the view display to shaded with edges. Let's delete the threaded hole provided for the strip pusher. Right-click on the threaded hole and select Delete. A delete window opens. Uncheck the Delete Aggregated Elements. Pick OK. Let's delete the draft provided for the die opening. Right-click on the draft and select Delete. A delete window opens. Pick OK. Let's delete the chamfer provided on the locator pin hole. Right-click on the chamfer and select Delete. A delete window opens. Pick OK. We need to slightly increase the size of the die opening and the locator pin's hole size. Create a position sketch on the top surface of the die plate. Pick the Offset command. Make sure the tangent propagation is selected. Select the die opening. Create an offset curve towards the outside of the die opening. Change the value to -1. Pick the Offset command. Make sure the tangent propagation is selected. Select the hole for the locator pin. Create an offset curve towards the outside of the hole. Change the value to -1. Make sure the sketch is fully constrained and exit the Sketcher workbench. Make a cut in the die plate using the Pocket command and up to last option. Click on Preview, make sure the pocket is getting created, and then click OK. Set the view to isometric and fit all in. Double-click on the die plate and check the thickness is 30 mm. We have successfully converted the die plate to die shoe with all the updates we made on the die plate. Save the die shoe. Swap the window to die assembly. Let's assemble the die shoe to die assembly. Click on the existing component command. Pick the product 1, which is the die assembly. Pick the die shoe from the file selection window. We have a part number conflict. Remember, we had saved as the die plate to die shoe. Hence the part number on the die shoe is the same as the die plate. We should have changed it. Anyhow, nothing to worry. We can change it now. Select the die shoe. Click on Rename. Enter the new part number as die shoe. Click on OK. Observe the part number of the die shoe that got updated. Click on OK. Use the manipulation command and drag the die shoe. Provide a coincidence constraint between the side ZX plane on the die shoe and the die plate side ZX plane. Observe the die plate being highlighted in the product structure. Provide a coincidence constraint between the front YZ plane on the die shoe and the die plate's front YZ plane. Observe the die plate being highlighted in the product structure. Provide a surface contact constraint between the die back plate's bottom surface and the die shoe's top surface. Update the die assembly. Click on Sectioning. Pick the tab result. Pick on Volume Cut. Observe the assembly got cut on the front YZ plane. Observe the holes are aligned correctly. Observe the screw hole, the counter bore hole on the die plate, the relief hole on the die back plate, and the threaded hole on the die shoe. Also, observe there are two diagonal lines. You can pick on the diagonal lines and move the sectioning plane. You can position the sectioning plane wherever you want and check the assembly. Position the sectioning plane on the strip guide plate fastener holes. Observe the screw hole, the counter bore hole on the strip guide plate, the threaded hole with a relief hole on the die plate, and the die shoe's relief hole. Observe the dowel hole, the dowel hole on the strip guide plate, the dowel hole with a relief hole on the die plate, and the die shoe's relief hole. Don't forget to check the hole alignment of all the holes with the sectioning command. Click on Cancel to exit the sectioning command. Set the view to isometric and fit all in. Save the die assembly. With this, we have successfully designed the die shoe. That's all in this e-learning module. Thanks.